Hi, this is Mrs. Nearing. In this video, we're going to talk through the formative assessment questions here having to do with mass spec. And as a reminder, before I get started, that there's a page here, page 4B, that has a reading on mass spec. There's also a video that I had posted earlier having to do with what we talked about in class last week with the POGL. So there is a reading and a video already out there, but I also wanted to go over these questions. So what we have here is we have some mass spectrum. And remember, what the mass spec does is it separates out various particles by mass. So each, what we say is each peak will correspond to a particle with a unique mass. So, for example, in sample A, there's only one peak. That would mean that all particles had the same mass, and that mass was exactly 122. So that's what that data is showing us. And then the y-axis shows us the relative abundance, so like how common they are. So like if we look down here in D, we'll notice there's 3 peaks. So there are 3 different types of particles, one with a mass of 120, one with a mass of 121, one with 124. 124 is the tallest peak, so that means that one is the most abundant. And one thing we can do from looking at these graphs is we should be able to, by glancing at, make a quick estimate of what the average mass would be of your sample. So like if we go back to A, there's only one type of particle in here. So they all have the same mass. So the average mass here would be 122 because all of them weigh exactly 122. Down here, it looks like most of them weigh 124, a couple of them are a little bit smaller. So I'm going to guess that the average mass is maybe like, I'm going to say like 123.9 or something around there. It's going to be pretty close to 124, but a little bit less than that. And then we can take a look at these other samples. So in this one, we have 3 types. So we've got 3 different particles. And it looks like 124 is the most abundant. And just from glancing at this, I'm going to say the average mass is maybe going to be closer to 123-ish, because most are 124, a few are 123, and there's only a few down here that are 120. Over here, there are 2 different types of particles. So there are 2 peaks, and most of them are 121, but a lot of them are 123. So I'm going to guess that the average mass here is going to be somewhere between 121 and 122. So it's closer to 121, but it's going to be somewhere in between these 2 values. And so we want to know which of these matches the element SB. And so if you look at your periodic table, SB is element number 51. So if you look at the periodic table, it looks like this. And then underneath it, you see this 121.76. So that means if you had a sample of antimony, that the average mass would be 121.76. So the one that best matches that would be this one right here. So it looks like there's maybe 2 common isotopes. 121 is the most common isotope. That's the most common version of this element. And so the average mass is going to be closest to 121. So that's how we would interpret these graphs here. If you look at this mass spectrum, it matches which of the following elements. So if you look at this, there's 1, 2, 3, 4, 5, 6, 7. There are 7 peaks. That means there are 7 versions of this element with different masses. Vocab note, these are known as isotopes. Isotopes, and we will go over this on page 8. So there's a reading kind of reviewing what isotopes are. This should be a review from general chemistry. And it looks like they're kind of, if I had to guess what the average is, I'd say it's pretty close to 96, because they seem sort of evenly spread out here, and 96 is kind of right in the middle, so that would be my guess. So now we got to go through and look at these elements. So NB, it might take you a little while to find these, because These might be ones that you're not super familiar with. They're kind of lower on the periodic table. But Nb is 92.91. Mo is 95.95. Uranium's around 238. Californium is 251. So the correct answer here would be MO. That looks closest to what we're seeing up here. 92.9, that's way too low. There's lots up here. So, and these are way off. These were tempting wrong answer choices because if you look at like uranium, it has an atomic number in the 90s. So these have atomic numbers that are close to these average masses. Okay, that's why they were in there as tempting wrong answer choices. But we want to identify something by its mass. So molybdenum has the closest average atomic mass. Average atomic mass. And remember, that's the number on the bottom. So if you look on the periodic table, MO, where is it? It's element number 42. It looks like this. And underneath it, we see the 95.95. That's what it looks like on the periodic table. Right next to iron. No, kind of below iron to the left. Okay. So those are those ones. This type of problem is a more conceptual version of a molar mass application. So we want to just rank these in order of increasing number of moles. So we want to apply the information that in order to find moles, what we basically end up doing is taking the mass divided by the molar mass. And it's asking us to compare 1 gram samples of all of these things. So you've got a gram of sodium chloride, you've got a gram of potassium bromide, and you've got a gram of potassium chloride. To find how many moles are in these samples, you would take the mass and divide it by the molar mass. And remember I said we don't want to use our calculator on this one, so let's just do a quick, approximation here. The molar mass down here, it's, about 23 plus 35, so it's about, 58. Okay. The molar mass of KBr, I'm going to say this is like, 39 plus 80. So this is like 1 over 119. And then KCl, it's like 39 plus, 35-ish. We could probably round some of those up. So it's like about, 75-ish. So this is how you find the mole. So notice that what we should notice is that when you are comparing things with let me erase this one. When you're comparing samples with the same mass, the substance with the largest molar mass, in this case that's the KBr, is going to have the smallest number of moles. And notice I didn't actually have to use my calculator at all. It doesn't even matter if I misestimate these molar masses. I just want to have a rough estimate here. So the one with the largest molar mass has the smallest number of moles, and the one with the smallest molar mass is going to have the largest number of moles. So the answer to this one is D. And then looking at this last one, we're trying to figure out how many atoms are in 2 grams of neon. So let me set this up. I have 2 grams of neon. And using my dimensional analysis, I'm going to convert from grams to moles. I'm going to use my periodic table. 1 mole of neon weighs 20.18 grams. And then I do one more step, go from moles to atoms. This last step we don't do very often. We more often just go from grams to moles, but this question's asking us about atoms. And we know that 1 mole of atoms is 6.02 times 10 to the 23rd. That's Avogadro's number. Just so you know, this right here is on your equation sheet. This is not something you need to memorize. You just need to know how to use it and where to find it. And so this is your setup. And I don't have to stop and plug it in my calculator because the question's just asking me, what does the setup look like? And so that looks like C. That matches my setup right over there. All right, so that's going over those 4 kind of check-in questions. If you have more questions about them, just let me know and send me an email or come by the afternoon tutorial. Thanks.